Alright, so we've already covered how to name basic alkanes like butane, methane, propane, and ethane. But what happens when they have extra substituents attached to them? Now remember, it's those substituents that are attached to the original carbon chain that make the molecule reactive. So what kind of a name would we give to these molecules? So let me draw a carbon molecule for you. Okay, so the first step that we want to take when we're trying to name our molecule. Now, see, for example, we might start to say, okay, let's just count across 1, 2, 3, 4, 5, 6. Well, that a 6-carbon molecule, a plain one, would just be hexane. So, but as you can see, this is much more than just a simple hexane, which would look like this. That's what a simple hexane would look like, and obviously this is not like that. So how would IUPAC have us name a molecule such as this one? Well, the first step is to find the longest carbon chain. Now, while we might think that it is hexane, straight across, 6 carbons, it actually isn't, because you can see that all these extra things that are attached to them, if we take a different path, we actually find a basic chain with more than 6 carbons. So let's say, for example, if we go this way, 1, 2, 3, 4, 5, 6, 7, okay, that would be 7 carbons, so that's already longer. But if we went instead up this way, it would be 7, 8. So that actually gives us an 8-carbon molecule with substituents attached. So I'm going to go ahead and circle those so we remember which chain we're using. Okay, and then I'm going to use the same color just to kind of number the carbons so that we can remember. 1, 2, but at the same time it's not really going to interfere. 3, 4, 5, 6, 7, 8. Alright, so the first step is to find the longest carbon chain, and we've done that. The second step is to number the carbons, and we've also done that. Now, what's important to remember when you number your carbons is, I started, for example, here, 1, 2, 3. You can see that there's already things attached at carbon 2, carbon 3, carbon 4. However, if I had started numbering from up here, 1, 2, 3, 4, the first substituent that we find attached would be on carbon 3. Now, while that might seem alright, IUPAC wants us to number the chain in such a way that the substituents have the lowest number possible. That's why we started over here and went this way. Okay, so now we're going to circle the substituents. We have one here, we have one here, one there, one there, and one there. Alright, well, 1 carbon attached to the chain here, and here it's 3 carbons. So, remembering what I mentioned in my previous video, that we can use, meth, eth, pro-bu to remember to mean 1 carbons, 2 carbons, 3 carbons, or 4. I'm going to write it here. Meth, eth, pro-bu. Alright, so if meth, eth, pro-bu means 1 carbons, 2 carbons, 3 carbons, or 4, then we can use that same technique to name the substituents on these molecules that consist of just carbon. So just like the basic chain is called an alkane, and so therefore the name would be methane, ethane with that ending, these substituents that consist of just carbons and hydrogens, now I haven't drawn all the hydrogens on here just for clarity, but they're actually there. So what these would be called is alkyls. alkyls. They're called alkyl groups. So the ending YL can just be attached to the prefix that will tell us how many carbons there are, and that's what they're called. So for example, this substituent that only has one carbon would be methyl. So that would be a methyl group. And this carbon that's right here has 3, so propyl. That would be a propyl group. However, what's the difference between, let's say, a propyl group, just a normal propyl would actually have 3 carbons in a row. So 1, 2, 3, one up here like this. 1, 2, 3. It would be attached like that. So, but nonetheless, this still has 3 carbons. So what would we call one that has such an arrangement? Well, it has a special name, and that's isopropyl. And iso just means that it's arranged in such a way that there's 2 carbons coming off of it like this. Let's say we had a substituent that looked something like this, and it had a branch of 3 coming off of it. That would be called neo. So in this case, where there's 4 carbons, 1, 2, 3, 4, that would be a neobutyl group. So anyway, so in this case we have isopropyl. So, and these are all methyl groups as well, because they just have 1 carbons and the ending YL for alkyl. So now to name the carbon molecule. Alright, so the way we do this is we first get the last name of the molecule, which has 8 carbons, so it's going to be octane. Octane. Okay, so now what we do is we count how many methyl groups there are, and we see that there's 1, 2, 3, 4 methyl groups. So what we're going to do is we're going to write down the numbers of the carbons on which these methyl groups occur. So we have, I'm going to write it down here, so we have 2 and another one on 2, and then so in between numbers you're going to write commas, and in between numbers and words you're going to write dashes. So I'll show you how that is. So we have 2, 2, and then we have 1 on the number 3, and we have 1 on the number 6. Dash. So we have methyl groups, but there's 4 of them. So we have to use an appropriate prefix. So to let the reader know, whoever's trying to figure out what the molecule looks like from our name, that there's 4 of them, the prefix for 4 is tetra. So in this case we would have tetramethyl. Similarly, if you only had, let's say, just 1 methyl group, you would just say methyl. If it was 2, you would say dimethyl. If it was 3, you would say trimethyl. And then of course if it's 4, you would say tetramethyl. Anyway, and so on with the prefixes. So, and also note that I wrote the 2 twice. You might be wondering, okay, well, why would I write that twice? We already know that it's on carbon 2. Well, there's 2 of them, and if you don't put the extra 2, you know, your reader might not know where that 4th methyl group goes. So you have to make sure that if there's 2 substituents occurring on the same carbon, that you write that number twice, so you know that that's where it is. Okay, so 2, 2, 3, 6 tetramethyl octane is what we have so far. But then we also have this group, the isopropyl group. So that's on the number 4 carbon. So we can write for that one 4 dash isopropyl. Alright, so now we just have to put all of these 3 names together. And how do we do that? Well, the way IUPAC convention is that you alphabetize the names. Well, except for the last name, the octane or methane or hexane or whatever it is. That's like the last name of the molecule. That will always go at the end. But the substituents are to be alphabetized. So in this case, iso, I would come before T. So we would write 4 dash isopropyl dash 2 comma 2 comma 3 comma 6 dash tetramethyl octane. and just like that. And so that would be the full IUPAC name of this molecule. Now, just one more thing that I want to throw in here, just so you know, is that just like I mentioned that you can have an iso group with with a branching of 2, and a neo group. Oh, I didn't write that over here. Neo. So this is iso, and this would be neo 1, 2, 3, 4. So butyl. That would be a neobutyl. So just like the neo and the iso, we can also have other arrangements, and that would be cyclic arrangements. So a cyclic arrangement, would look something like this. So let's say we had 3 carbons, which would be propane. Well, obviously now we can't have like a cyclic methyl, because there's, it's only 1 carbon, so there's no way we can make a loop out of that. Out of an ethyl, we couldn't have a cyclic either, because it's just like this, and there's no way you can, wrap around to make a cyclic compound that way either. But with propyl, with 3 carbons, we can. It would be an arrangement like this, and that would be just drawn like a triangle like that. So that would be a cyclopropane. And then if we had 4 carbons, 2, 3, 4, it would just be like that. That's cyclobutane. 5 carbons would look like that, cyclopentane, and then 6 carbons, cyclohexane. So, just keep in mind that these are also very common in organic chemistry. And so let's say, for example, if we had substituents attached to something like this, then the last name would be, cyclohexane. So in this case, if we had, let's say, like a group attached there and another group attached here, then we would number this. Let's say this is carbon number 1, 2, 3. We would have, 1, 3 dash dimethyl cyclohexane. So that's how you would name something like that. So just keep in mind that that's also very common in organic chemistry. All right, thank you.